Okay, let's go for today's experiment. In this case, we have circuits in series and circuits in parallel. We have right here circuits in series, and right here we have circuits in parallel. Okay, let's do it. When we're dealing with circuits in series, it's found that the current is constant and the voltage, right, of the battery, in this case, is the sum of the voltages through the resistors. We call this the voltage drops. Okay, let's prove that. Let's prove that the total voltage is equals to the voltages through the resistors. Great. Now also let's prove that according to the theory, the total resistance is the sum of the resistors in the circuit when it's in series. Great. Also let's prove that. Let's do it then. From the theory, let's find the total resistance, and from the experiment, let's measure, right, the voltage of the battery, and let's divide that by the total current, or the current through each resistor because it's constant, right? And now let's compare those two resistances, correct, using the percent error. Great. Now let's go for the other case using voltage. We know that from the theory, when we're dealing with circuits in series, the total voltage is the sum of the voltage drops, right? Let's do it. Let's find each voltage through each resistor, right? Then let's find the total voltage. Also, from the experiment, let's use the total current found before, it's right here, right? Times the experimental resistor, or resistance in this case, and let's find the percent error, right? They're supposed to be very close. Great. Now let's go to parallel circuit, right? This is the diagram for this circuit, correct? But in this case, the voltage is constant and the current, right, is split by three paths, right? So current 1, current 2, and current 3. From the theory, it's found that the theoretical value is going to be current 1 plus current 2 plus current 3. Let's prove it today. Okay, to do that, let's divide voltage using Ohm's law, right? Let's divide voltage over current 1 plus voltage over current 2 plus voltage over current 3. And let's find the theoretical value. From the experiment, okay, let's measure directly, right, from the circuit, right, the current, and let's find the 2. At the end, let's compare these two quantities to find the percent error. Again, they're very close. Finally, let's go to the resistance in parallel. According to the theory, right, the resistance in parallel, the total or equivalent, is just 1 over R1, 1 over R2, 1 over R3 inverse. Okay, let's prove it today. And then let's go for the experimental value. It's gonna be voltage over the experimental current, right? This one right here, correct? Let's find the values and let's find the percent error for each case. Great. Now let's go to set up the experiment, right? And let's provide all the values that are required to do all of these calculations. Okay, let's do it. Let's go for this experiment. In this case, we have this breadboard that we are using, right, for this experiment. So we have resistors. This is 100, this is 200, and this is 330 ohms, right? 100 ohms, 200 ohms, and 330 ohms. Okay, for today's experiment. Great. Let's do it one more time. This is 100, 200, and 330 ohms. Perfect. Those are the resistances. Again, one more time. This is for today's experiment. We have R1, R2, R3. Now let's calculate, right, the electromotive force, also the terminal voltage and the current, right, and the voltage drops for the case of circuits in series. Okay, let's do it. So this is our circuit, right? Now let's add the battery, correct? We have the battery, right? So we have positive, okay, it goes right here, or negative, doesn't matter, right? The idea is gonna be the same. Okay, one is positive, one is negative, right? Either way, let's calculate the electromotive force. What is the electromotive force? Okay, let's do it. We have the ammeter right here. Let's go to voltage. Okay, the electromotive force is the voltage of the source, in this case the battery, without being connected to to the circuit. Okay, let's find it. As you can see, we have 0, 0. Now let's find the electromotive force, right, of the battery. Yes, let's do it. So it's gonna be, in this case, okay, hurry. I need to make a good contact, right, for this one to have the right value. This is one more time. I just did it, but we need to make again a good contact, right, to the batteries. Okay, look, it's gonna be about what, 638. Can you see it? Okay, 638. That is gonna be the EMF, right, electromotive force. This is the voltage of the battery before, right, is connected to the circuit. Now let's connect the battery to the circuit. Okay, great. Let's do it. So again, this is our voltmeter. Okay, this is the circuit right here. Correct. Now let's connect the battery to the circuit. Let's do it. Perfect. It goes in this way. This is one terminal. Right, this is the other terminal right here. Perfect. Now let's find the terminal voltage. Let's compare that to the EMF, right, quantity. Okay, perfect. It's done. Now let's find the terminal voltage. Now let's go back and check the voltage, right? Let's do it. So we have one terminal right here, one prom right here, another prom right here, right? Okay, perfect. Look, it's gonna be a little bit different. It's 6.31. Before it was 6.38 and now 6.3. It's less, right? Why? Because now we're taking into account the resistance of the battery. Right here, resistance of the battery. Correct? Okay, great. Now we found then the voltage, the terminal voltage is gonna be positive. Even though here is negative, right? Look, we change only the direction of the current, right? And we create positive values. See? So it's gonna be, before was negative. Now let's make it positive, right? Positive right here. Got it? The sign. Great. Now this is the voltage, the terminal voltage, right? Now let's go to find, what else do we need in this part? Look, we found already electromotive force voltage. Let's find the current. Okay, the current of the circuit. In that case, okay, let's move this to amps. Okay, let's go to this multimeter to amps. Let's go to, let's say, 20 milliamps. Okay, let's go to 20 milliamps. Hopefully it's gonna be enough. Okay, great. Now let's break the circuit. Okay, let's break this circuit. Now let's connect this right to the circuit and measure the current, right, that is on this, oh, it's right here. Look, on this circuit. So the current is about what? 9.88, right? That's the third current, 9.88. You can see right here, right? 9.88. Great, perfect. Now let's check. We found already, right, the current right here. Now let's check the voltages. B1, B2, B3. Okay, great. Let's return the battery. Okay, hopefully you're seeing everything. Okay, it's right here. Okay, great. Now let's go back with the battery. Perfect. Hopefully it's gonna be okay. Okay, great. Now let's go to the voltage drops. Okay, let's go. It's in parallel. Okay, but before, let's go to voltage right here. Right. Okay, let's do it. Okay, hopefully you can see it. Can you see it? Okay, great. Now let's go to the first one. Okay, these are in parallel. Let's touch them. Right. So this is the voltage dropped. Okay, one more time. Not making good contact. Okay, this is for, come on, what happened? Okay, this is for 100. Okay, now for 200 ohms. Okay, let's do it. Right, it's for 200 ohms. Perfect. Now for 330 ohms. Okay, let's do it. Do you see it? Okay, great. Now we found, look, this is 329, plus what? Plus, what is this? 190 something plus, right, oops, plus 1, then gonna be close to, right, that terminal voltage, which was what? 631, correct? Now let's prove that again. In the previous in introduction, right, we need those quantities to do the calculations. Okay, great. Now let's go to the other circuit, which is, right, in parallel. Right, by the way, look, this is the way how we work with the breadboard, right? We have one resistor right here, and now we go to the next one in this way, correct? Because these are wires right here. We connect all of them the same wire, right? Or the current should go through the wire, and we are creating a short circuit. So we need to go, right, for each, right, case, taking different wire, right? Otherwise, gonna be again in short circuit. So this is again series, means only one path. Perfect. Now let's go to the other case, right? Circuits in parallel. Okay, let's do it. Well, in this case, look, we have this. Let's use the same circuits right here. Okay, now let's start with okay, this one is 100. The next one is 200. Always using the same line, like in this case. Let me see if we can see it. Okay, it's gonna be this one. Okay, I did it by myself. Okay, I can't believe it. Oh my god, what is happening right here? Okay, one more time. This is the second one. Let's use this one right here. Okay, another one. The other prompt goes right here. Okay, I did it finally. Okay, and the third one, let's use another line. Let's use this one. Always again starting from, let's say, positive or negative, and let's go to the other right terminal. Again, it's gonna be the same. Okay, look, these are now in parallel. I can't believe it, I did it by myself. Okay, in parallel. Now let's go from this terminal to the other terminal of the battery, right? So let's jump, use a jumper right here, right, from here, right, oops, to, with the same line, to, hopefully it's the same, right here is the same. Well, it doesn't matter right here because all of these are connected to the terminal. Okay, the next one, the one must be in the same row, right? Okay, it is the same row right here, correct? Let's go to the terminal. Okay, the next one, where's the next one? Oh, right here. Okay, must be the same row. And right here could be any lines right here, right? Because this is connected to the same terminal, right? Any lines for the battery. Okay, let's say right there. Got it? And we have our circuit in parallel. Great, I did it. Perfect. Now let's find what? Okay, in this case we're looking for the voltage and we're looking for the current. Okay, let's do it. So let's connect, what do we have right here for voltage? Okay, let's connect the battery one more time. Okay, this is one terminal, another terminal right here, right? Perfect. I'm doing it by myself. Okay, great. Oops, next time I need to buy a larger right board. This is too small. Okay, let's see, you can see it. Okay, hopefully you can see it. Perfect. Okay, now let's make it this way to make sure that is good. Okay, perfect. Now it's connected. Now let's find the voltage, the terminal voltage, which is required right here. Let's do it as we did before, right? We need this prompt right here, right? And the other one is the other terminal right here. Perfect, I can't believe it. Okay, look, now this is the voltage terminal, right? Let's make it positive, you know, it's positive. It's gonna be what, 5.9, great. Volts, I can't believe it, great. Now, what else do we need? We need for this circuit the experimental current. Okay, now let's go to calculate the experimental current. Great, let's do it. So we have the battery one more time, correct? And now let's find the experimental current. Okay, perfect. So With this, we have all the data, all the information, correct? Now let's do the calculations according to the previous analysis, right? And let's prove that the series, the sequence in series and in parallel are correct. Okay, thank you. See you later.